Hey guys, we're on Unit 4, and this is day 6, and we're talking about rigid motions off the coordinate plane today. So in our warm-up, it says we have a trapezoid, QRST, and it's graphed on the set of axes below, and they want to know which transformation will there be no invariant points. Okay, and in the first one, it's talking about the x-axis. So if we were to reflect over the x-axis, our trapezoid would look like that. And right here, notice S didn't move, and so S would be invariant. But they're looking for no invariant points, and so choice 1 is not going to be our choice. Okay? If we were to reflect our trapezoid over the y-axis, I think you guys can see what point wouldn't move. And our trapezoid would look like this. And under that reflection, R would be invariant because R didn't move. It was on the line of reflection, so R is invariant. But that's not what we're looking for. So now we can try over the line y equals x. Remember, y equals x is the diagonal line that goes through the origin. And I think you guys can see that because Q is on that line of reflection, Q will be the point that doesn't move, and so Q will be invariant. So I'm thinking it's our last choice here. Y equals negative x. If you're not sure what it looks like, we could graph it in our calculator. Okay. But you're going to notice that all 4 of the points, if they got reflected, would end up all over here. None of the points are on the line of reflection, and so they would all move, and there would be no invariant points, and so choice 4 would be our answer. Okay, a little bit tricky. Easier to do when you actually do the reflections versus just thinking about them. All right, so let's see what we have down below. Oops. And in number 1, says describe a single rigid motion that maps triangle EXM. And I'm just going to do a highlight of triangle EXM. So they're talking about that triangle. Mapping onto triangle AXM. AXM. All right. And you guys can see this too, that E needs to go on to A. First letter goes to the first letter. So E has to go to A. X has to go to X. So X doesn't move. Okay. And then M has to go on to M. And so M doesn't move. So I think you guys can see how that yellow triangle can get onto the blue triangle under a single rigid motion. And remember, rigid motions, we have 3 of them. We have reflections. That's doing a motion of flipping, but the triangle is staying the same size and same shape. Okay. Translations. That's doing a motion of sliding, okay, but the triangle stays the same shape and same size, or a rotation. Rotations are also rigid motions. They keep the triangles the same shape and same size too. Okay? And so in order to get this yellow triangle onto the blue triangle, in order to get E onto E onto A, I think you guys can see that this is going to be needed to flip. The yellow triangle is going to need to flip onto the blue triangle and everything will match up. All right, so this is a reflection. So we'll use the shorthand with just a lowercase r. And we have to flip over the line, which would be XM. Okay, so this is a reflection over XM is the line of reflection in this picture. Okay, all right. We'll go down to number 2. It says describe a single rigid motion that maps triangle AEC, A to to E to C. So this triangle here needs to become triangle BFD. All right. So again, play the letter game, but A needs to go on to B. Right? A needs to go on to B. E needs to go on to F. And C needs to go on to D. C needs to go on to D. So I think you guys can see that if I just push the yellow triangle over to the right, that it would fall, that A would fall into B, that C would fall into D, and E would fall into F. And so by pushing it over or sliding it over, this is a translation. Okay? And that's our rigid motion that would map the yellow triangle onto the blue triangle. Except when we say translations, we usually give like a left and right movement and an up and down. Since we're not on a graph, that's hard to do, but we can say what vector it slid along. If you guys remember vectors from the other day when we were doing translations, that would be our vector. A would have to go on to B, E would have to go on to F, and C would have to go on to D. And there's our little translation vectors. And we can name any one of those vectors to describe our translation in this picture. So we could say it's a translation along vector AB. Or we could have said along vector CD, or we could have said along vector EF. Okay. If we wanted to notate it, it'd be a capital T, and then our subscript would be the vector that we're sliding our triangle along. Okay, like AB. Or we could have said CD or EF there. Okay. Okay, guys. All right, I'll see you guys on the back side of notes.